All right, hey guys, it's Greg Jones for Engine Builder, and welcome back to another episode of Intellectual Horsepower. Today we're talking all about cylinder heads. We have Mike Sanders. He is the Director of Product for the Edelbrock Group. We have Rick Roberts. He is a former engineering director for Edelbrock and now a consultant. And of course, we've got Pat Musi of Pat Musi Racing Engines. Guys, welcome to the show. Appreciate you guys being here.
Glad to be here.
We appreciate you inviting us, and we're excited to talk about cylinder heads today and the Edelbrock Group.
Absolutely. And cylinder heads is an exciting topic. You know, a lot of guys, want to be doing more things with their cylinder heads. It's one of those components on the engine that you can really push the envelope with to get, more power out of the engine. Beef up the valve train, do a whole bunch of different things. So I'm excited to talk with you guys at Edelbrock as well as with Pat, because we get both the manufacturer side of things as well as, what's going on the engine builder level. Mike and Rick, I'm going to start on the manufacturer side. Let's talk a little bit about, what you guys are looking for when you're manufacturing, cylinder heads for various applications. What are some of those things that go into the process?
The initial, start of a development project, one we want to look at what the market looks like. I mean, is it a viable market for Edelbrock to get into? How many vehicles are made? Is it something that we need to invest in EO opportunities, for EPA and CARB? And then from there, we start to make some financial decisions as far as how we're going to approach that. In a lot of different ways, it's easy to come up with something that's cool and say, hey, this is a great idea because it's fun to do. But on the other side, there's certainly a business aspect to this that we have to look at. Once we get past all of that, that's where the fun really starts to begin. And that's where the engineering team, guys like Rick and Pat, give us good feedback on what they've learned, lessons learned, experience in racing. And then we take, a combined knowledge of, all of us, and we start to think about the design and what that customer's need is really going to be, whether it's from an engine builder standpoint, the commodity, enthusiast that just wants to buy cylinder heads to run on his hot rod and drive around on the weekends. And all of those take a big precedence in how we develop a cylinder head, or at least pick which one we're going to do.
Yeah, absolutely. And Rick, I'll turn to you to kind of maybe elaborate on, what actually goes into that particular casting or machined, cylinder head in terms of, what you guys are trying to do or achieve.
Once we get the basic sort of recipe, then we in engineering would start to ask ourselves, okay, is there something that can be improved upon here without compromising what the end goal will be? In the early days, developing what is now our Performer RPM line, the watchword was kind of like, okay, it basically same as stock in terms of the architecture. And for the most part, we did that. But what we did do that many times the factories didn't was we would look at the ports, the port flow. Can we put a bigger valve in it? Can we, improve upon the design of the port? In the early days, we didn't do CNC porting. It sort of didn't exist back then. So you couldn't really qualify ports as well as you could doing them by hand. We'd do one by hand, and then we would do what you have to do to be able to cast it. See, that's the other aspect of this, and maybe a lot of people don't really think about, is you have to be able to make it. It's sand. It's made from pieces of sand that are glued together. Well, and making these sand cores is kind of like making a waffle. You put the sand inside this box, and you got to be able to separate the box. Well, then that means that restricts what the shapes can be, and that can sometimes restrict what the flow is. So there's all these compromises that have to be made. For the most part, a lot of our heads, it has to fit on the stock engine without changing a bunch of other parts. So we're kind of restricted to that. We do make manifolds, so if we wanted to make a head that required a special manifold, we'll do that. Guys like Pat don't want to have to monkey around, making their own manifolds or anything like that. They want to be able to buy parts that fit. So that's the engine builder aspect of it. We have to be aware that we've got to be able to give them a package of parts where everything fits together and even, works together as far as performance. I mean, the package with the Edelbrock group now having comp cams, we can work camshafts. Between camshaft and cylinder head, you've pretty much defined what this engine's going to do. But for a lot of stuff, we don't really change a whole lot from stock unless it's more of a racing type of head. Then, the gloves are off, so to speak. We've done that on some of our big block Chevy heads that we worked with Pat. We moved valves around, moved spark plugs around, not a lot, just a little bit, but enough to make a difference. So, but it all has to come down to something that we can actually make in our foundry and machine and that will fit together with the other components that we sell.
Yeah, no, that certainly makes a lot of sense in terms of what you guys need to achieve. At a bare minimum, that it fits an engine appropriately, and then it kind of goes from there. And Pat, I'll come to you. Again, on the engine builder side, and as someone who works with Edelbrock, on a consulting type basis and doing a bunch of different things these days, what are you looking for in the manufacture of a cylinder head, and ultimately, what are you trying to do with an end product that goes onto a race car?
Well, I just want to take a little step back. And originally I came to Edelbrock to do the nitrous program. Vic brought me in, and they took me out to the foundry. I've always been intrigued to be involved with a foundry where we can get a cast. And I come from the days of an OEM part over the counter, hours and hours of welding, hours and hours of grinding. So I've been there from day one on the cylinder deal, but now being involved with a company like Edelbrock and Rick and Mike, we can develop stuff that the average guy can go buy, bolt together, doesn't have a cylinder head on, push rods, hidden ports, and all this nonsense, take it off, start grinding, and then it fits. But at the end of the day, he's picking up all the research and development we do on the racetrack, even though they're bigger or really high-end deals. It trickles down to that user. Like Mike, you said, the normal hot rodder gains all that advantage from having a valve train that sits still, a correct valve job. I mean, it's just really neat to see where the cylinder head has gone now. And I'm biased, but I think we have the best casting. You have your own foundry. Vic was pretty smart back then that did the foundry. Rick, we spoke about that. I've welded on about all repairs or whatever. And I'm telling you, the Edelbrock casting is bar none the best we've had. But I'm excited that we can give it to all our, whether you want to call them, small engine builders or big engine builders, we can give them a part they can really look up to, bolt on, and go race, and have it sit together is another big deal.
Yeah, I actually want to elaborate on that a little bit. So, some of the focus with an Edelbrock cylinder head is really to make sure it's easy for not only the end user but our engine builder distribution to really use them. I mean, Pat owns and runs an engine building shop, and if he gets our cylinder head and has to tear it apart and redo a valve job and home guides and deck it, that's time and effort that he has to spend that he may not be able to charge, without the customer knowing up front. So it's really important for Edelbrock and this group to make sure that we're supplying high quality castings that are ready to run out of the box, with the exception of maybe some small checks. Pull them apart, clean them, make sure, since Pat's name's on it or other engine builders' names, it gives them the opportunity just to do the basic stuff that they do to make sure their engines are good to run out of the box and not have issues or comebacks. Because ultimately, that's just going to cost more money for them, and we don't want that. We want to have a premium product for them to use.
Yeah, absolutely, absolutely. Mike, I think that's a good segue into maybe more of that discussion around the development of a cylinder head. Obviously you guys do a lot of stuff to come out with new products and heads that fit different applications. Do you want to elaborate on the development side of things and what kind of things you might try within a tried and true cylinder head to enhance it?
Yeah. So, one neat thing that we've been working on, or really have acquired, is our new 3D core printer. And this core printer really allows us to be able to really push the leading edge of the envelope as far as casting design. One particular area of that is draft. If we want to, for instance, move a head bolt column to the maximum area without having draft in it, we can actually print it without that, and it gives us more space between the ports to actually move that port without having thin areas and casting issues. So, I feel like, we're, with this in-house 3D core printer, it's going to allow us to do much more prototype development and then get us to the point where we're going to be releasing cylinder heads, manifolds, superchargers, things that people generally don't have the opportunity to release because that technology exists within our foundry and not many others. So, Rick, if you want to elaborate on that, that's one thing I want to touch on. Obviously, we go through other steps of development. From, it's still an art to develop a cylinder head, anywhere from a hand ported model to digitizing to CAD development, all the way through valvetrain development. Pat knows a lot about that, working with Jessel and other companies out there that support high-end racing applications. It all comes together as a package. You really have to look at the entire engine combination, even all the way down to the piston for cant on a valve, to make sure that the valve is away from the ring lands in the piston. Everything. We're trying to take it all into consideration.
Yeah, Mike's right about that 3D printer. I'm really excited about where we can go with that. He's got a good point too, in that one of the problems we had way back in doing a cylinder head was you really couldn't prototype it. I remember when we did the 24 degree big block head, we did that one with Pat. That was one of the first projects we worked on together. We had something before we got Pat involved, and he put some suggestions into it that made it even better. I'll never forget that, Pat, when we first sent those to you, and I think you put them on something and ran them, and I remember you telling me you were impressed. That's still those words still ring in my ear. Pat, is kind of like a hero to us. He's the guy out there doing it, and part of the reason I got into this is I love racing. So I hold his opinion in very high regard. And when he told me that, it really made me very, very, very proud. But in order to prototype that, we had to take an existing casting that we had, and like Pat said, weld on it and do all this stuff, and then hand port it, and it never, you never really get it exactly the same every time hand porting it. It's not like CNC porting. And then you run it and you make changes and until you get what you think you like. These days we can do a lot of that in CAD ahead of time. And even with tools like CFD and stress analysis stuff, we can learn a lot engineering wise with simulation things before we ever even go to a physical part. But then, we do print a usually print a 3D plastic that can be ported and messed with and run on a flow bench. You can then scan that. If you make changes to it, you can scan that. So we can go from physical world to virtual world and back again. There's a lot at our disposal these days as far as development tools. But this 3D printer just offers so much more in the way of prototyping. Like Mike said, I mean, I'm really excited. One of the biggest and hardest things in a cylinder head is the water jacket. I mean, it has to be able to cool adequately, but you've got to be able to make it. And if you saw one of these things, I mean, it's this complicated, series of passages, and it's fragile, and they're hard to make. And it's certainly hard to design one so that you can make it from a single cavity core box. And as Mike said, that's largely because you've got to be able to make it so it has draft and that the box will separate. With a 3D printer, you don't need that. So we can make exactly what we want, wall thicknesses that we want. We can put water where we want. Sometimes you don't want to cool too much, say, on the intake side. I couldn't help looking at Pat's heads. Recently, I went up to watch him race in Las Vegas. And their heads are made from billet because of what they are trying to accomplish. I looked at where they put the water in that, and it's mostly around the exhaust. The intake doesn't necessarily need a whole lot of cooling. So there's all these kinds of things that we can do and take into consideration when we have this kind of capability at our disposal.
Yeah, absolutely. That's cool stuff. And so, guys, how often are you using the 3D capabilities versus, those molds that you were talking about kind of back in the day? I assume you still use both to some degree, but is one still ahead of the other in terms of use?
So right now we're starting to develop more production-based castings with the 3D printer. The cool part about the 3D printer on the development side of cylinder heads is the fact from model to casting an actual cylinder head or bell housing or even a manifold, it can be anywhere from 2 to 4 weeks. So it's really good as far as time to market, or at least to prototype something in a short period of time, run it through our R&D center in Memphis at Comp Cams, really do a test to make sure that the port design was correct, the valve train was correct. We just introduced a Plex system in our R&D facility that tests in-cylinder pressure now, so we can look at combustion chamber efficiency. And really all of that feedback gives us the opportunity to look back at the design, make small changes, and then build other prototypes in short periods of time that we can retest and see if those changes made a difference. And from there, that's going to put us into, I really believe, a leading edge in the market, because we're going to be able to do this so quickly and get cylinder heads to market with high technology fast. And all of that's going to trickle down to our middle market cylinder heads as we learn more, and then down to our lower end, like our E Street brand. So we're just going to continue on using these advancements that we've invested in as a business to help us develop these heads and keep them moving, keep technology moving. That's what we're all about.
Yeah, definitely. No, that's cool stuff. And Mike and Rick, you guys both just brought up, a number of different, kind of things on the checklist when it comes to developing a head. And Pat, I want to have you weigh in a little bit about, how the valve train plays a role, the cant on a valve, how it integrates with the piston, that type of stuff. Maybe, can you talk a little bit specifically about maybe the big block Chevy head and how that's changed over the years, that you've been doing this, in terms of, how it used to be to now, kind of what's desired out of a head like the big block Chevy?
Well, the valve train is huge, that's come along. I remember in '81, the late Danny Jessup, we grew up together, and he came out with the rocker system. We immediately went to India with low ET with that new deal. But it's developed so much. And Rick has to look at all that, and that's what we do. We look at the valve train. You can have the best port, and Rick, you correct me on this one, but if we can't get the valve open, what good is it? So you need the thing to stay together, and it's just really, really critical. We've come up in valve sizes, and a canted valve, you have typically 4.5 degree on the intake. You have about 4.5, so they're trying to hit each other. You have a quipping deal, so you have to keep moving things away from each other. Sometimes you got to give up a little bit depending on bore size, but everything's evolved so much, and everything we learn, let's say on our big engine, we apply to this. It's a canted valve deal, a big block, if that's where you're going with it, and meaning the valves are pretty well aimed at each other. You're moving the intake away, like you said, Mike, away from the ringland is critical. Moving it away from the bore. So there's different applications, different bore sizes. Look, we thought 4.375 bore was huge back in the day. Now we're at 5 inches and 4.600 for some of the things we're doing. So the bore size has also a lot to do with where the can is, where the valve location is. So, and then the valve train, like I said, has to move with it. And there's so many deals that you have to check before Rick finishes a port. We've kind of made the agreement. Let's make sure we can get a valve train on it. So I hope I answered some of your questions. I ramble sometimes because I know it all, and I think everybody does. But if you have any questions for me, shoot them at me.
That's Pat knows this. I learned some lessons on this. I got very enamored with ports probably about 15 years ago or so, and didn't really think so much about valve train. And some very wise people kind of straightened me out on that. It's kind of like, if you can't turn the RPM, it doesn't matter how good a port you have. So you got to look at the whole picture. We on our big block 24 degree head, that kind of evolved for, I think, in the industry. We used to angle mill heads. I don't know how many. I started off working in a porting shop, and we used to angle mill big block heads 0-125 across the deck, and that rotates at maybe not even a degree, about 3/4 of a degree. But that was how you got the chamber size down where you want, because you unshroud everything and you open the chamber up. Now it's too big. So people want a certain size chamber. 115 sticks in my mind back then. This is 40 years ago, for crying out loud. But that's kind of how it evolved. So most people took what was a stock head, which is 26 degree angle, and then made a 24 degree. But they didn't really look at other aspects of it. Well, when we came into it, we had the benefit of knowing that. And also history, as Pat pointed out, was, you want to get that intake valve away from the cylinder wall if you can. Usually you can crowd the exhaust valve a little bit, and it doesn't hurt much. And as Pat said, when we came into it, a 4.5 bore was very common, whereas the earlier ones, 4.375 was about as big as you could go. But with the Siamese bores blocks, you could go to 4.5. Now they're at 4.625, I think, on a lot of them. So what I did with our 24 degree head was I moved the exhaust valve away from bore center, took advantage of the fact that we got, an extra 60, 80 thousandths, and then moved the intake valve toward bore center, away from the wall. Put an extra degree of cant in it so that the head of the valve moves away from the cylinder wall at high lift. Just all these little things. You lay a competitor's 24 degree head on the table, and then you lay ours and look at them from 10 feet away. They don't look any different. But look closer. Look closer. There's a reason that we did things the way we did. But all of that, like Pat said, affects valve train. So you got to make sure you don't compromise anything there. It's an overall package.
Yeah, absolutely. There's a lot that the head has going on, between the valve train and the airflow. So I wanted to elaborate on that. You guys both brought up the ports, but you also brought up the valve train componentry and how that's interacting. But ultimately, when it comes to performance and elevating that, is one more important than the other? It seems like, a lot of people focus on the ports. Is that the case? Or, is there something else that guys should be looking at if they're trying to really elevate the performance they're seeing from their heads?
I think the reason there's a focus on ports is because usually there isn't a lot people can do about valve train. What are you going to do? Are you going to start welding up guide bores and remachining? That's a big deal. That's a big deal. So, but getting in there with a grinder and changing things a little bit, putting a bigger valve in, say, changing a valve job around, that's something a porting shop can do. But, making radical changes to the valve train, that it's almost like that has to happen at the manufacturer level. There aren't too many engine builders unless you're in some kind of a competitive racing class where, and I'm talking about something like Pro Stock or something like that. You do what you got to do there. If you really think there's going to be an advantage to changing the position of a valve or whatever, as Pat mentioned earlier, they did this back in the early days when all they had was a GM casting, and you just got to weld everywhere in it, change things that you need to. As far as the valve, which is more important, I mean, if you've got a certain horsepower level in mind and an RPM you got to run, that valve train's got to get there. So I mean, as long as it does that, then fine. You can refine your ports and all of that. Not to be dismissed here either, as far as what goes on is the combustion chamber. And, not only is it port flow that matters, but how the port sets up what goes on in the combustion chamber. And Pat and I have had discussions about this lately with his stuff and some of the things that he's doing with his combustion chamber designs, which is, with all that nitrous that he's using the combustion process and avoiding any kind of detonation and things of this nature are just crucial. So, it's not, a lot of guys get enamored with the flow bench, and then you got to get, how much of your flow numbers. And that's like fish stories. The first liar doesn't stand a chance. I mean, everybody's flow bench is different, and it's hard to compare flow numbers, but people still want to know what they are. And I'm not saying it isn't important, but what goes on in that combustion chamber and in setting up the combustion process and the shape of the chamber, position of the spark plug, all those things are also not to be dismissed as important.
Yeah. Pat, I'll let you weigh in. It sounded like you wanted to maybe say a few things on that topic between, what's more important out of the cylinder head.
Well, valve train to me is a big deal, depending on the RPM you have to go to. But something I want to mention, our heads right now have to fit on an OEM lifter bore package. So you have all these heads out there, like our head, for instance, but it's a custom cam, lifters are moved. We don't have that option because of the racer that we're after and the volume mic. Like, our 12 degree will go on a 4840 factory lifter bores. Once we get there, and me and Rick have spoke about, a racing version, we could do it as good as the other guy can do it. Obviously, we do it. We haven't been outrun. We can make it happen. But right now, we have to work in the confines of our camshaft location, our lifter location. Rick knows all that, and fix the valve train, fix the things we can. But if we tell the guy, well, you got to buy a billet block and you got to put lifters here and you got to buy a custom cam, we're not at that. We can be at that level. Don't get me wrong. Don't take that the wrong way, because we're going to get there. But right now, that the market we're at, I think we have a killer product that you can bolt on, go race it, hands down better than what's out there. But if your question is valvetrain versus port, I always take valvetrain. Rick, you know how I am about that. I'll give up a
Yeah.
little port if I can get a rod to tweak in somewhere, or get it to not throw valvetrain off. I mean, me and Danny, I guess that comes from the Danny Jessel relationship I've had for all these years. He was big on valvetrain. I mean, just a little ratio change in a rocker arm can throw things out of sync, and just destroy parts. But I really think what we have and what we're selling in the market we're after, we have the best part. As an engine builder, I'm excited. I can bolt them on, close my eyes, have a valve train, give the customer a valve train part number, or supply it, or Mike, you guys can supply it. And that's how we've built around it. But I think eventually our plan is to go a little farther. But right now, because of COVID, we slowed down a little bit. But I really see our deal coming together and getting this cylinder head out that a guy can close his eyes, bolt it on, go fast, give him a recipe. End of the day, best valve train out there, best casting, best port we can fit in that package.
Yeah, no, absolutely. That makes a ton of sense. And I think most people would agree that, maintaining that valve train and making sure that that lives and is durable for your application is probably way more important than the airflow and the port side of things that you can ultimately change around a little bit. So that certainly makes sense to me.
The flow bench, the dyno numbers, it's the W on the scoreboard and the ET. I mean, come on, guys, we've all seen it, and we get our head compared to something. Like I said, you're moving lifters, well, you can't compare apples to oranges, but apples to apples, come get some.
So I wanted to dive a little deeper into ports specifically. Pat, I want to start with you. Maybe talk about some of those port shapes that you've seen over the years. What kind of port shapes do you prefer, and what port shapes have you seen the most success with? What's kind of your preference there?
Our intake, has gone to a big radius. I call it an oval, rectangular. Used to be, back in my day, it was about square. Is how it started. It's amazing what it's evolved to. But Rick will probably back me up. Mike will back me up. It's all come down to a radius on the four corners. And then the short turn we've raised. I mean, and that's really a big deal on the exhaust, getting that exhaust up and get the short turn up. Those are all things you could fix without worrying about push rods right now, if we're on that subject for what we're doing. But like Mike's point, big push rods, then the port needs to be moved. Then you could widen the port. All that stuff comes into play. But right now, I think if we stay focused on our 12, our 24, you're limited to that package. And I guess my preference is the oval. Rick, you have anything to add to that? Or
When I'm laying out a port, I start with, I have a kind of a recipe that I use for what the cross-sectional areas need to be. The thing about rounded or oval corners versus square corners, there's less surface area. I mean, a circle, for the area it encloses, has the least surface area. Surface area is friction. So, there's something to be said for that kind of a thing. Why don't we make round ports? Well, because push rods get in the way. And here we are back to the same thing. You got to get around the push rods somehow. But the cross-sectional areas through the port, I view it this way. The more on an intake port, the more that you have to turn the port, the kind of bigger that the area needs to be over top of the short turn. to get around a corner, you have to slow the flow down, or it's going to basically skip off the short turn like an airplane wing stalling. Anybody who's ever done development work on a flow bench for any length of time, you get a port to a point where it's just about perfect, and then you open the valve just a little bit more and you hear buffeting, and that's the short turn letting go. So, this is a key. And like I said, I have my own little kind of proprietary recipe that I use for laying out cross-sectional areas. But, you can only go so far when you've got limitations of where the push rod and all of those kinds of things are. And what we talked about earlier with stability of the valve train. Tendency now is to, we know opening an exhaust valve against the pressures present in the combustion chamber at that initial opening point is that they may be many hundreds of PSI, unlike that with an intake port, so that you want a stiffer, you want a stiffer exhaust push rod. They're going to 9/16 push rods on the exhaust. That limits what you can do with the port. So, it's wrong to focus on any one aspect, I think. I mentioned earlier the combustion chamber and how the valves are laid out in relation to each other and to the spark plug in the combustion chamber is an important thing. If you have the leeway to use a custom piston. I mean, if you're going to use an off-the-shelf piston, you can't just move the valve wherever you want because it's going to potentially hit. So this is more for when the unlimited kind of thing, if you can do whatever you want. So you have to think about the whole package, like a hemispherical combustion chamber or a Hemi. You have an absolute straight shot with a Hemi port. They flow extremely well, but that in terms of combustion type of thing, that has what I would call more of like a tumble kind of port where the flow almost like a wave crashing on the beach kind of thing as it comes in. Whereas a wedge head, like a big block Chevrolet, particularly the so-called bad port on a big block Chevrolet, the port is aimed at the wall, the cylinder bore. Well, that creates more of like a tornado or a swirling kind of motion in the combustion chamber. And all of that's going to affect how much power you get out of it. It's going to affect the way things burn and the way the pressure rise occurs. And whether or not you're going to get detonation, you got to think about keeping fuel stirred up in there, whether it's fuel injection or a carburetor. So all these things have to be taken into consideration when you're designing a port, laying out valve angles, all of that.
Rick, well, thanks for that information on the ports. That's great info that I'm sure these guys can benefit from understanding. Guys at home watching, you might notice that Pat Musi had to leave. He's out in Michigan for a race weekend and got called back to the track here. So we wish him the best of luck this weekend they're racing. We got a couple more things we'll cover here with Mike and Rick. Guys, we talked a little bit about the importance of the valve angle as well as the valve job on a cylinder head, being pretty critical to its performance. So guys, you want to talk a little bit about what those different valve angles and the type of valve job that you do does to the cylinder head?
So kind of lending itself to what Rick was talking about as far as the valve angle, the bowl area, the design there, and how nice wide bowls slow that air down through the pinch and it allows it to take the turn. The valve angle in a cylinder head, as you start to tip it up, if you build the port correctly and you start to raise it and move it over, it actually helps with that line of sight onto the valve itself. And I think, you start to get a more efficient, not only air, but fuel flow through the cylinder head to utilize the valve jobs that are designed into these cylinder heads. It's all, like Rick said, a combination of things coming together to really optimize the way that the air and fuel mixture moves through the ports, and then utilizes the valve job to shear fuel for optimum cylinder combustion. So, talking about valve jobs now, moving down the port into that bowl area, Rick and I earlier this year, we started to talk about Edelbrock valve jobs and how we really thought that we could improve the way the profiles looked on it, to really help with some of that fuel shear, help that air take the turn, and help that combustion efficiency. And I'll push it back over to Rick, because it's funny, we both drew different valve jobs at the beginning of the year, and we compared them, and they were so similar that it was like a match made in heaven. We were like, yes, we're gonna put these in our performer RPM heads, our Victor heads. So why don't you take it from here, Rick, and kind of talk about how we did that and what we came up with.
Yeah. Well, on the let's stick with valve jobs, because I want to come back to valve angle. But let's talk about valve jobs here. If Pat were here, he would say, you know what, guys, a half an inch up into the port from the valve job and a half an inch into combustion chamber from the valve job, that's where it all happens. If that isn't right, you're not going anywhere. So, the valve job and the way in which it blends in to both the bowl and the combustion chamber is just absolutely critical. I remember at the porting shop I worked at, we used to do, fully ported heads. And the owner at the time came up with the idea of, well, let's just do our really nice valve job that we do in that head. But instead of porting the whole thing, we'll just carbide blend it. And these were men who ported heads all day long. So we're talking about an absolute master head porter doing the blending with a carbide tool. And we'd sell it for, 30-40% reduced price because there's not so much work done in it. Well, on the dyno, and at that time on a 400 horsepower small block Chevy 350, it didn't make any difference. The fully ported set of heads versus what we called a race ready set of heads back then, just by blending the valve job carefully. And I use that word with emphasis, carefully. And the other thing with valve jobs is, let's not forget, way back in the day when I first started in this business, we did valve jobs with stones. You literally ground each angle one at a time. To do a 5-angle valve job was a lot of work. Nowadays, with SERDES and then the fixed turning stuff that a lot of the people have, you can do any kind of valve job you want. So that's changed the whole landscape as far as valve jobs. I know of one manufacturer that has the capability of the fixed turning, that they will, when they're R&Ding a valve job, they will change the width of an angle by as little as 3 or 4 thousandths, change an angle by half a degree, go back to the flow bench, optimizing, just getting the absolute best they can out of it. That's a little overdone, in my opinion, but you can do it these days. In the old days, it was tough. So technology brings with it improvements that you couldn't otherwise realize. As regards valve angle, I like to think of it this way. In the old days, we used to measure cross-sectional areas in a port job that we did by filling the port with rubber, like RTV, and then we would push the plug out, and you could measure cross-sectional areas on the plug and things on this rubber plug and things like that. Well, if you imagine having that rubber plug and sticking a valve in it and rotating that valve to a more upright position, i.e. reducing the valve angle, what happens to the intake opening? It raises up. So, we got into this thing of changing valve angles, but I look at it as, the overall architecture of things. If you stand the valve up, you've got to raise the opening along with it in order to really see the benefit. You can only go so far on that before you start running into other problems. For example, on the late model Hemi, I call it the small block Hemi. It's the one that's in all the Challengers and stuff that you see out there now. We have a head for that, and it was pretty much a copy of stock. Now that has, I think, an 18-degree intake valve angle. That's not really stood up that much, but look at where the opening is to the port. It's way up in the air. It's a straight shot, like Mike called it, line of sight. Man, you can't get any better than that. There's no turn that you have to make at all. But what's the disadvantage of that? And this is where the factory missed it, I think, is they still had a relatively short valve. Well, when you do that, the spring pocket starts interfering with the roof of the port. They didn't put a long enough valve in it. We're introducing a head at the SEMA show here in a couple of weeks where we fixed that problem. So you ought to take a look at it. It makes a big difference. So again, it comes back to the overall architectural package. A valve angle is just one aspect of it. How much you cant the valve is another. Where you put the intake port opening is yet another. And then how long a valve you have to have as a result of that to get the spring pocket up and out of the way. Then what does that do to the weight of the valve? Now you're back to valvetrain and RPM stuff. It just all comes back, guys, to that overall package of things. You can't just look at one thing and say that's the magic bullet. And valve angle people got enamored with valve angle, in my opinion, too much. And it was like, who can have the shallowest valve angle? Well, I don't know if Pat was on right now, I don't know what the valve angle is on his 958 engines, but I guarantee you it's not 9 or 8 or 7. It's probably more like 10 because of what he's doing with it. So anyway, there's a lot more than just valve angle that goes into the overall architecture.
Yeah, Rick, I think that's some great information there about valve jobs and valve angles and what all goes into that. Again, making a complete package within the cylinder head. Mike, I'll toss it to you if there's anything else on top of what Rick was just talking about that you wanted to mention.
Yeah, so one thing that we also did in this new Gen 3 Hemi design, not only did we move the spring pocket out of the high flow side of the intake port and lengthen the valve, but we also moved the towers that the rocker bar bolt to. And we not only moved them up, but we rotated them closer to the intake side of the port. So the valve train geometry, or the pivot length of the rocker arm itself, has a better footprint on the tip of the valve to allow a higher lift capability. As we start to develop intake ports that are super efficient and high flowing at high lifts, we need to make sure all of that is in combination, working together to make sure that we can achieve those high lifts to make the cylinder head work at its fullest potential. So there's definitely a lot of things going on in there. Just wanted to add that little in there.
Yeah.
Valve train stability, valve train location, and then port development all work hand in hand together.
Well, guys, obviously we could talk all day, probably multiple days, about cylinder heads. But I'll leave you guys with one last question. And to our viewers, if you guys do have questions for Mike, Rick, or Pat, make sure you guys are leaving that stuff down in the comments, and we'll be sure to pass that stuff on. But just to wrap up, Mike and Rick, I wanted to ask you guys about what you see going forward in cylinder head manufacturing and development. What are some of those things that you guys might be, looking to do in the next year or so when it comes to that type of stuff? And what do you think engine builders might be looking for out of cylinder heads in a couple of years down the road?
So My best guess or forecast for what they're going to be looking for. I mean, really a high quality casting, um, something that they can use to their maximum efficiency as far as building an engine. We're going to look at a lot of different applications from mild to wild. We're really going to focus on the technology side of our cylinder heads, which will allow us to help trickle down some of that to the middle market cylinder heads and even the lower E Street stuff, like these valve jobs Rick and I have been talking about here. Um, you're really going to see a lot from Edelbrock Group coming up in the future here. I think a lot of people are going to be excited about our racing heads that we're really developing now, almost on a daily basis now. Rick's already hard at work upgrading ports, valve jobs with Pat's insight. He's a consultant for us as well. We're really going to have a lot of exciting things here in the future, and I'm super excited. And I think the whole team is really. I'm super proud of everybody.
Yeah, I look to the future with a lot of optimism. I think we've got a great management team right now. You know, we went through a lot of changes with the move from Torrance and the joining together with Comp Cams. But I feel with Mike and our president Chris Douglas and the ownership group, their direction I think now can be realized in a lot better way maybe than what we could during that kind of transitional period. I just think there's so many tools that, from my standpoint as an engineer, that we have that we can use now that we didn't have before. Simulation of not only casting and flow and dynamics of the valve train, all these things we've been talking about. This ability to 3D print prototypes, as we mentioned, and even working with outside people who may want to avail themselves of that capability. I mean, we're not above doing that. Really getting back into the race game. I mean, Pat is CNC porting cylinder heads at his place. We're set up in North Carolina to really feed the racing head program. And we're looking forward to doing new things in those areas. Pat and I and Mike have talked about a variety of new products. And we really haven't had the opportunity to do that because of everything that we've been through lately. So I know from Pat and my standpoint, we feel like we got the band back together again. We're ready to go. And we've got every opportunity in the world to succeed at this. So I think keep your eye on Edelbrock Group. I think there's going to be a lot of good stuff coming out of us as far as cylinder heads in the days to come.
Absolutely. Well, that's all well said. And I know from my seat, we're excited to see what you guys get into here in the coming years. And Mike, Rick, just want to say thank you to you both there at Edelbrock for being on the program today. And of course, to Pat Musi for joining as well. Guys, we appreciate you at home watching this episode of Intellectual Horsepower. Again, if you do have questions for these guys, leave that stuff down in the comments and we'll be sure to pass it on. Hopefully we'll do a second edition of this topic and get even more in-depth in the future. But again, thank you guys for joining and thanks for watching. And we'll see you guys next time.